Hello, this is John Marmaduke. I'm a member of Team 78, and I'll be doing a demo of our Streaming Wars application. So our application utilizes Spring Boot in the back end, and the back end is running here, and we have a command line interface for the front end, which we'll be using up here. Now our Spring Boot is hosted on Amazon Web Service, and we have exposed various endpoints that the command line interface can call. So we'll actually be discussing more about the Amazon Web Service implementation and how it affects our scalability later on. For now, I'm going to mostly be demoing with our command line interface and talking about how we implemented authentication, authorization, and robustness. So to kick it off, I'm just going to go ahead and start with the help command. This just lists every command that can be used by users as well as the arguments necessary to use them. So pretty handy to have just for documentation. So let's just keep that in mind. And to kick things off, why don't we go ahead and create a streaming service with the create stream command. So if we look right here, it says create stream, short name, long name, subscription price. Cool, let's just go ahead and create Netflix. And we'll make the subscription price $11, but uh-oh, look at that. We've got an error because we're not authorized. So, well, look at that. This is a perfect segue into our authorization. So essentially how this works is a user needs to log in, and when they do, they are given a specific session ID, which will then determine their privileges. And based on those privileges, it will, they'll have access to specific endpoints and commands that they can use. So let's go ahead and log in as a streaming service user. Login successful. We are now logged in as stream. Now, if we rerun that create stream command, it should succeed, and we can go ahead and display it. Just to ensure, yes, stream Netflix, long name Netflix, subscription price 11. Perfect, exactly what we wanted to happen. Now, let's just force another error here. Let's try to create Netflix again. There we go, error invalid operation. This time our message being streaming service short name already exists. So this and I guess earlier when it said not authorized are two examples of how we have implemented exception handling throughout our application. This is in an effort to increase our robustness. We scan for errors, scan for redundant data, scan for improper inputs, and when they are found, we push out an error message to the user, as well as we try to make the message pretty detailed to give them an informed decision-making ability to adjust their inputs in the future and hopefully resolve their issue. So I'm going to be forcing a few more errors throughout the demo just so we can kind of see some more instances of when this occurs. But I'll try not to be too redundant. So great, let's just keep on moving. Let's try to display a stream that doesn't exist, just some random one named boot. Great, so here's another example. Short name boot not found, error, invalid operation, exception handling in work. Cool. One last thing, let's just go ahead and create demo. Let's make it old, and the long name for this will be older than 80. And we're going to go ahead and give it 200 members. Oh, look, there we go. So yeah, we're still not authorized for demo. So basically, we logged in as a streaming service user, which would give us access to all the streaming service applications. If we wanted to access the demo, we would need a role. In this case, we do have a specific role that is associated with demographic services, as well as the all-powerful admin role. So in total, there's an admin role, a streaming service role, a studio role, and a demo role. For now, I'm just going to go ahead, log out of stream, and log in as admin, just to make this a little bit smoother for us as we walk through this demo. Cool. We're now logged in as an admin. I can go ahead and make that demographic group, and that works. So now I'm just going to quickly run through those commands that were given to us in assignment 5 just to show that we've properly implemented them. First things first, we're going to work on updating a streaming service. So just a reminder, I'm going to display Netflix just to show what we already have in place for it. And then I'm going to go ahead and use the update stream command for Netflix. I want to make the new long name just like Netflix Inc. Sure, I know that's not technically correct, and then we'll make the subscription price $15 instead of 11. It says update stream, and if we display the stream again, great, Netflix Inc. And $15, we've raised the subscription price successfully. Now let's go ahead and update our demographic group. So again, we made this old demo group, older than 80, size 200. We can go ahead and run update demo on old. We'll make the new long name older than 85, push it back a little bit, and by doing so, we've lost a few members. We're down to 180 members. And if we display old again, we can see now it's older than 85 and the size has been reduced to 180. So that's all working properly. So the last thing we want to show is update an event. So in order to make an event, first we need to create a studio. And in this case, let's just go ahead and make Disney. Long name will be Walt Disney Co, I guess. And I think, yeah, actually for studio, we just need a long name and a short name. So go ahead and hit enter there. Again, if you ever need to review the command inputs, you can just use the help command to pull up that documentation. So now that we have the studio, let's go ahead and create an event. So for an event, we need a type. So that's going to be movie. For the name, let's make it Finding Nemo. Not 100% sure what year it was produced. We're going to guess 2003. And then for the duration, I'll put 120 minutes. Studio is Disney, which we just created. And I'm going to set our licensing fee to $1,000. Now we can display, oops. Let's just go ahead and display the events. And we can see right there, Finding Nemo, just as we made it, is an event. But let's go ahead and see if we can update it. Update event. And then we to update the event, we need to put in the name. So Finding Nemo, the year, 2003. And then I'm going to say this is the director's cut, and we'll add 5 more minutes of unreleased Finding Nemo footage, as well as increasing the licensing fee to $1,250. Okay, so it looks like the update event went through and displayed again, and great. We have those 5 extra minutes and the licensing fee went up. So now we have to show that these fail if there has already been financial calculations for the month. So let's go ahead and process some of that by first, we need to add this event to add us to a streaming services offering. So to do that, we can use the offer movie command. Offer movie is a streaming service command. So let's see. For offer movie, we need to include what streaming service we're going to use, which will be Netflix, the movie or the event, which will be Finding Nemo, and just the year produced, 2003. Cool. And now let's go ahead and watch that event. So we can do a watch event, and creating a watch event, this will go ahead and it's essentially we choose the demographic group that will be watching it. In this case, we're going to watch it with old. And we're going to say what percentage of them are watching. We'll do 10%. And the streaming service is Netflix. Event name, Finding Nemo. And lastly, the year again, 2003. All right, so now we've watched this event with the 10% of the old demographic. So now financials have been calculated, which means we shouldn't be able to update the commands like we did. Let's go ahead and start with update stream again. I'll just cycle on back, update stream. Let's just, let's just change the long name back to Netflix Inc. and let's change the subscription fee all the way up to $30. Okay, unable to update subscription price if the streaming service has been accessed in the current period. Great. So basically, you can't update the subscription price until the next month when the month is rolled over. Just as expected. So let's go ahead and show that we can't update the, let's go ahead and show we can't update the licensing event of a movie. So I'm going to try to raise this price again to $1,300 now. Similar error, unable to update licensing price. Again, financials in the current month. As soon as the next month rolls over, you should be able to update it again, no problem. And lastly, let's just try to update our demographic group one more time. Older than say 88 now, and now there is 130 members. Error. Yep, can't change the number of counts during a pay period. So again, just having to wait till the next month. So those all work as intended. The one last additional command we need to make sure works is just retract movie. This is just to remove a movie from a streaming services offering. So in order to retract movie, let's say we're going to retract from Netflix. Mouse out of the way. Retract from Netflix. We'll say we're retracting Finding Nemo and 2003. Cool. And now no more offerings are displayed. Finding Nemo has been successfully retracted. So yeah, that's basically it as far as running through these commands. Just a reminder, we also demoed the robustness additions we made with our error exception handling, giving messages to the users, and we have specific authentication and authorization, as I already detailed before. So one last thing I just want to do is go ahead and run some test cases. Basically, these are going to be the same test cases that we used in assignment 4 for the individual implementation. And then I'll run a diff on the results and just show that it's as we expect it to be. So great. First things first, I need to just reset to clear the database and make sure there's nothing funky before we run the batch file. And now that that's been handled, let's just run the test file. And it's just chugging along here. It's give this a few seconds to process. So again, we will be touching on the Amazon Web Service aspect after this. Gabe's going to step in and give that a description. Once this is done, I'll just show that the diff file in place is as we expect it to be. So for when we run through that, we have this test scenarios folder. I'm going to run a diff, and then we're going to get a new file, a results file that'll populate right here. So well, we just got to be patient for a minute while we run through these tests. In case you're wondering, this is Pippa. That's one of my cats. Here's my other cat, Nova. You can see them both together. All right, back to waiting. Okay, I mean, I guess I don't want to be too redundant here, but just a reminder, so for authentication and authorization, we have different roles. We have the admin role, streaming service role, studio role, and demo role, each of which will generate a specific ID session token to determine privileges. Okay, great. Now that's done. I'm on Windows, so I have to run the diff through my Git terminal. Let's just go ahead and run that now. And there we go. We can see the results file here. Files of the test file and the stream test initial results are identical. So these results were the expected results from when we ran the individual implementation in assignment 4. So great. That's the end of my part of the demo. Now we'll hand it off to Gabe to discuss the Amazon Web Service.
Hi, my name is Gabriel Levasseur, and I am on Team 78 of the Streaming Wars Group Project Implementation. And I'm going to do a quick demo of the scalability of our system. So I'm going to use a simple tool called Apache Bench to test how our system handles 50 concurrent requests at a time over the period of 10 seconds. So I'm going to run this test. You can see the output of the previous one. But I expect it to come back very similar, where our system is able to handle around the range of 70 or 75 requests per second, which it does. And the average response time of the request is 641 milliseconds, and the maximum is 1.9 seconds. In order to achieve scalability of our system, we leveraged a couple services offered by AWS. One, AWS Lambda functions, and the other one being their MySQL database offering. We decided to use AWS Lambda functions so that we would not have to manage any underlying servers. And AWS handles the scaling of Lambda functions based on the number of incoming requests into your system. So it can scale to meet the demand of your users. One of the side effects of using AWS Lambda is that you have to ensure your system is stateless. That is, it does not store any data on its local disk or in files. And that is why we decided to use AWS RDS as a database so that we can store all of our data not on disk, but instead into a MySQL database, which any Lambda function can read from. So I'm going to stop sharing this screen. I'm just going to switch over to the AWS Dashboard to just give a quick walkthrough of our services within AWS. So here are the metrics for the number of database connections made to our system. So as we have more requests, there are a higher number of connections. And you can see the spikes, which correspond to some previous load testing I have done. For purposes of our demo, we have, in order to keep the costs low, we have chosen the smallest instance type, which has the lowest performance. We've also chosen not to use or take advantage of any read replicas. In a real production scenario, you could have any number of read replicas. They can scale horizontally, so you can have between 1 to 10, and they will scale based on CPU, and that will help distribute the read or select statements load on your database. In order to handle a higher number of writes into our database, you would scale the size of the writer up into a larger instance class. You can only have one writer at any given time. If you get to the point where you can't scale up any higher and you need a higher write capacity, you would have to investigate using database sharding in order to continue to scale the system. And now I'm going to switch over. This is the dashboard for our Lambda function, where you can see some metrics on the spikes on the number of requests that come into the Lambda function, and then some data on the duration that the Lambda function took to execute. So here you can see the maximum request time. This is in milliseconds. The maximum request time was 12.63 milliseconds. The average was 708 milliseconds, and the duration was 162 milliseconds. So this shows off our system is able to scale to handle any number of requests that come into it and provide our services to a high number of users. I just want to talk about one also extra benefit of using AWS services, and that is availability of our system. Since AWS manages the underlying hosts and it runs those hosts within different geographically separated regions, there's a low chance that our server would not be available, or our service would not be available to our users. And this is something AWS provides for you. We do not need to manage those servers and the availability of them ourselves. So that's another reason why we decided to use AWS services. And that's it for the demo. Thank you for tuning in, and thank you.